Hello, everyone, and welcome to today's EIP-7928 Breakout call. It's the 11th breakout call, and it's January 28 today. So, looking at the agenda, let's start at the beginning. Let me quickly post the agenda into the chat, such that everyone can have a look. So, the first two items were basically already discussed at ACDT beginning of this week, but I think it would make sense to get an update from Stefan where we are at. There were some delays, as far as I know. It would be great to have an update there.
Yeah, sure. From the last ACDT, we decided to include a change that would remove the gas spent, I think, from the receipts, and agreed that we would add it and delay the DevNet 2 until next week at the latest. Hopefully, we can get it running a little bit earlier. Yeah, it got changed. Exactly. But otherwise, also maybe to summarize, maybe not everyone was in ACDT. From DevNet 1, I think it went pretty well. We got most clients to be in agreement. We didn't have too many forks anymore, even with the EVM fuzzer running. So that's very great. And we also got most of the clients syncing. There were still a few hiccups, but in general, it was working pretty well. And now I hope that with DevNet 2, we can look into the optimizations more. But let's talk more about the spec clarification, because I think it would be great that we could tie everything of that up and get everything in DevNet 2 of the open issues that we're going to discuss next. And I think I've added everything to the spec sheet from what we're going to discuss next.
Perfect. Thanks for the update. So just to confirm, it looks like 7928 is not blocking anything regarding DevNet 2, and we are ready to go basically, but it's more about other smaller EIPs like 7778, right?
Yeah, that's pretty much it.
Okay, here. To echo what Jared is saying here in the chat, regarding 7778, there was recently a change that reverted it back to keeping the receipt as it is, so it should be done pretty soon or pretty easy, I would say. But let's see. Great. So what was the latest then? When will DevNet 2 launch? Do we have a date for that yet?
So I'm aiming for next week, Wednesday, as the latest date that I want to launch DevNet 2. And we'll see. I will be testing the clients regularly to see how we get on. But that would really would be great if we could launch earlier. I don't know how the development is going on. It would be great to get some client updates. I think the last update from everyone that I got was last Wednesday.
Awesome. Yeah, and this plays into the next topic, the client optimizations. We already saw in the Discord that Geff and Beso are both ready, having the flags ready to enable and disable the optimizations. For example, parallel execution, parallel batch IO, and parallel state root computation. Is there someone from the other clients that could provide an update on how far they are with regards to optimizations and if there will be flags to turn them on and off?
Yeah, I can give an update for Nethermind. So working still on a parallel transaction execution and state root computation. Haven't started with the batch read yet. But yeah, just been focused on preparing for the DevNet for now. But yeah.
Awesome, thank you. Maybe someone from Ref or from Aragon? Otherwise, it's also not a problem if we don't get updates that soon, because importantly, we need at least a few clients to do the benchmarks on top of a BAL DevNet. So having Geff and Beso is already a good start, and I think we should then get the benchmarking going as soon as possible. And for that, yeah, I mean, I will leave that to Jochen anyway, because he's the expert there. So I'm not sure how to best tackle that, but I would assume we will just have a mainnet shadow fork and do the benchmarking there. Maybe Jochen, if you're on the call, you want to say a few words to that?
Yeah, it depends, I think, on what exactly we want to test. I think we want to benchmark the impact what block access lists could have. I also think this is also like about because you could implement block access lists to just be consensus compliant, and you could also implement the block access list with the optimizations in there, so like parallel execution. I think this is at least something what we should do. And what we will then do to benchmark this is we have the benchmark test, but we will then benchmark the same client, which does not have these optimizations enabled, against the client which the same client against the client which has these optimizations enabled, to see what the impact of these of the block access list is.
Perfect. Yeah, sounds good.
And oh yeah, sorry, and to mention, like this should be done on like indeed a shadow fork of mainnet, because if we do this on empty state, oh, Karim is already asking this. So what network is being used for this? We need a network with state, and that the simplest way is to just do a shadow fork of mainnet. because if you would run these things on like empty state or like consensus tests sized state, so like a very small pre-state, then you will see almost no influence at all because the state reads are there super fast, so you would not have any performance increase there. So we need like a big network, and we can also see what we could also do is also run these on top of bloatnet. So this is like a shadow fork of mainnet, but increased in size, to see also what the impact is if mainnet size, well, it will of course increase over the years, what the impact is then on an even bigger size. And when do we expect to have the shadow fork ready? Well, I'm not sure if someone from if PandaOps is, Stefan is here, but I think this the shadow forking, it can be done instantly. So we can just run it on top of a shadow fork, well, in an hour.
Yeah, I think as soon as we have Devnet 2 running, we can focus on the optimizations, and when the optimizations are in and they're working as expected, I think we can start the shadow fork.
And maybe then a question, this DevNet 2, is this planned to be a shadow fork of mainnet or like an empty network?
DevNet 2 would be an empty network, but we would increase the gas limit to, I think, 150 million, so that we can also have a reasonable state after some time there too.
Okay, that's fine. Yeah, like the benchmarks are of course also somewhat different than just testing the networking aspects. So we can also run these locally on like a shadow fork to test the impact of state.
Yeah, I'm
this
not 100% sure about this, because even if we put the gas limit to a billion, we will not be able to generate like reasonable state within a short period of time. So I think we should focus those tests purely on a shadow fork or on bloatnet. Especially bloatnet might be very interesting because it gives us already a glimpse into the future, basically. So, and then we basically focus the DevNet 2 more on everything consensus related and testing all the new changes that come with DevNet 2. For example, the BAL payload or the BAL EL block separation, the new engine API methods, and so on. If that makes sense.
Yeah, I agree with that also.
Yeah, I think that what we then do is like DevNet 2 is, because it also makes sense to not immediately test the DevNet, and then do the stress testing on like a very specific benchmark network, so like a shadow fork of bloatnet or mainnet or whatever, and then use that for the benchmarks. Yeah, I think that makes a lot of sense.
Yeah, and just to be on the safe side, maybe we should first clarify on ACDE or ACDT with clients if they are actually ready for higher gas limits, because I don't know if we can just bump it up to 150 and then suddenly we run into weird RLP size limits or whatever. So just to double check, I assume clients will be fine with that. So every client might be fine with just bumping it up, but just to double check there. We don't need to trigger like running into the 10 megabyte uncompressed size limit or anything. Perfect. Anything else regarding this discussion point? Just to summarize, I think we will now also start a shadow fork and probably a fork of bloatnet, and then also basically unblock the benchmarking efforts by having 2 clients already ready, BSO and GEF, that can be used to test parallel execution and batch IO at the same time already. Anything to add? Yeah,
maybe to clarify a bit, or maybe to ask that we are all on like the same line of thought. So the parallel execution is using the block access list to well, run multiple transactions in multiple threads. And the batch IO is actually used to read from the BAL to parallel fetch from the disk, right?
Yeah, exactly.
Okay, so those are like 2 different optimizations. And I think it is nice also for the benchmarking, for the benchmarks to be able to test these individually. So no, not individually, but maybe like with only parallel execution and with parallel execution and the batch IO to see what the impact is. So we can also measure the impact of these of adding the reads to the ball, what the impact of this is.
Exactly. Yeah, this will be the very interesting comparison that we've postponed this until we have definites, and now it's time, I would say. Basically, finally determining, do we need the state locations in the block time access list or not? Are they actually worth it? And the best way to do so would be exactly what you said, comparing it with the batch.io enabled and then with batch.io disabled, and then seeing what are the numbers. And if we do that on a realistic state size definite plus on a higher guess limit, we should get numbers that, yeah, we should get confidence for Amsterdam. Great. Anything else?
Yeah, just asking what for Karim, the clarification, like the
The
background
statehood.
Yes,
Yeah, I think we can ignore it. I think we can ignore it at this point because this is like an optimization that is solely dependent on the post-transaction state diffs being in the block. So this doesn't actually tell us anything about should we keep the state locations or not. So we can use them. We can also turn them off depending on what the client supports.
Yeah, I think this is like an optimization which is not really influenced. Like if you just think about like the reads, if we would remove that or not, like this will not influence the right, the state would also trigger the read IO. Yeah, okay. Interesting. Yeah, something to keep in mind, maybe.
Yeah, exactly. Great. The second agenda item that we have on today's agenda would be spec updates and clarifications. So there were 3 updates, nothing new. So the first one was the engine API methods. And there was some discussions in the PR regarding, do we need the engine API methods and for what they are used for? Also, Mikhail had some comments there. Mikhail, are you on the call? Do you want to briefly tell us why the engine API methods are needed and your thoughts around it?
Yeah, okay. So, hey everyone, I'll try to summarize. So, if I believe that BAL is will be part of the CL block of the beacon block, right? Is that correct?
Right. Yeah, that's correct. It's in the execution payload.
Yeah, it's part of an execution payload. It's quite similar to transactions, so there is no possibility for the execution layer client to process a block without BAL, right?
Right, yeah.
And if we make it as a requirement for a consensus layer client to pass BAL to EL alongside to the payload, then we have this dependency, kind of like that the CL block has to keep BAL on its side in its storage. Like it would have to keep transactions, but we have these deduplication methods like for that allows CL to basically request block payload bodies which are consistent of transactions and withdrawals today from EL side. So if we make a requirement that BAL is required to pass to a new payload call, and EL will get it from CL in a regular case, then we likely have to also introduce this piece of data into these payload bodies methods. So some CLs really use these rely on those methods to deduplicate the data and reduce the disk storage impact. So yeah, in this case, yeah, if it's required, then we have to kind of provide these additional additional data that can be pulled off from EL. So if it's the other option, basically, yeah, make val as a as an optional field of a new payload call. And in this case, EL will have to either execute transactions without it or look into its own network via def-p2p, extract val, get val from there, and basically execute a block. So, and yeah, optional means that sometimes CL will just have it. When the block is gossiped, it will come with val included, and then CL can pass it to EL. So there's kind of like two options here that I see. I don't know if it's clear or not. So yeah, let's probably discuss it.
Yeah, thanks a lot. To me, it makes a lot of sense. What I don't get is why the optional val field is like even on the table. To me, it feels like treating the block level access list same as we treat the transactions, and thereby forcing CL clients to either keep the vals around or blind them, which is kind of what CL clients do in order to deduplicate transactions. So basically, instead of storing the whole val, CL clients would only need to store the val root and have those two engine API methods available in order to retrieve the full val if needed. To me, this feels like very clean. With the optional val field in the execution payload, I'm not so sure, because essentially the block level access list will be necessarily needed on the EL side, because you cannot validate the full block without having the block level access list. So yeah, I'm having difficulties wrapping my hand around optional, about the fact that it's optional. I know that this is more like a technical thing here to make sure that CL clients can just get rid of it without blinding it. Is that correct?
Yeah. Yes, it is.
Mm-hmm.
So, like for a normal case, val will be passed from CL because it gets it from gossip. But in the case when CL is like syncing, is in a sync mode, then it will just pass the payload without val, and then the EL side will have to fetch it from the network. I don't know. Does it make sense or not? So
it does make sense. So it's very much we're talking about syncing here too. So essentially, the CL could provide other CL peers with beacon blocks, even though those beacon blocks would not contain a full execution payload because the val is missing. And the other CL that is syncing would then pass the beacon block execution payload to its EL without the val, and the EL would then have to figure out where to get the val from, and the EL could then use def-p2p for that.
yeah. And then what will happen? Yeah, sorry.
Go ahead, please.
Yeah, and then what will happen in the case when there is nothing to fetch? So there is like imagine there is no syncing case. EL has all the data to process a block, but CL does not give does not pass a val because it's optional. It's an optional field. Then EL will not be able to synchronously process block and get back with a payload status as it happens today. It will have to go to the network, and it sounds like asynchronous stuff, so it will have to return syncing instead of the payload status, something like that. It makes the thing a bit more complicated then.
Right, yeah, and we could have done the same with transactions, right? So there's nothing speaking against doing the same for transactions. So we would suddenly actually introduce this new path that might be better, but even though it's like different from existing code paths.
Right, but what I see about transactions are pretty necessary. Actually, there is no possibility to process a block without transactions, but you could process a block without this block level access list, couldn't you?
You can process the transactions at least, but you would not be able to tell if the block is valid or not, because in the end you would still need to
Right.
compare so you would at least need the bal hash, right?
Yeah.
So the CL could also provide the bal hash. Then the engine API call to the EL would also need to provide the bal hash, and then it would work.
Right.
Maybe a question to the EL clients. Is there already has some EL team already implemented BALs into dev P2P for SnapSync, for example?
I'll just say on the Geth side, we've slated this to actually use these for the snap sync. That has been pushed back to something we plan to do in Q2. I mean, we can, of course, yeah, I'll just leave it at that.
Okay. Yeah, maybe we will just have to revisit that topic sometime later on. I would say, correct me if I'm wrong, Mikhail, but I would say right now it seems like the simplest approach would just be to keep it as it is and implement those two engine API methods that are defined in this PR that I will now post into the chat. Let me quickly do that. So I think this was the right one where we have defined those two new API methods. And those would essentially be needed by the CL in order to help other CL nodes to sync, because CL will be able to prune the bal, but then when it comes to helping other nodes sync, they need the bal again. And because the EL will store the bal, there needs to be this engine API method to retrieve it.
Yep, that's correct. And I think it's easier to leave it as is and probably change it later on. So I don't know. It's also a question to CL client developers. What do they think about it?
Right, yeah. We don't have many CL developers here in this call, unfortunately. I think most of them are busy with EPBS anyway. But yeah, this will probably come up in the future again, and we should think what is the cleanest solution for such things, and if we should just keep on doing the same that we do with transactions, or if there would be a smarter path. Awesome. Is there anything else on that topic, on the engine API method? Otherwise, we can go on to the next item, which is further clarifying what access means. We have had discussions on that, like when do we count an account as being accessed versus not yet accessed, having to do with the different phases. And this PR here, I will also post it into the agenda, just clarified that further. Unfortunately, I saw it got merged automatically before I could respond to Joachim's comment here. I will still do that and incorporate that. But I think right now we are in a good state because Felipe and Rahul have created tests for all those edge cases, and clients have been passing those tests. So I think we are quite aligned on that topic. But just to make sure, is there anything on the access topic? I know that Jared and Gary brought it up in Discord recently. Is there anything we should discuss?
Yeah, I guess I'll just say, so the proposal we brought up, basically it was about changing the logic for whether or not we include a like when making a call and executing the gas handler, depending on how much gas there is, and it goes out of gas at some point in the handler, we will or will not include the target as an axis. And the reason we made this proposal was that it greatly simplified the change there that need to be made on the side of Geth. But I think Joachim brought up a pretty good point regarding basically I think the current spec is good because we need to we can't create a situation where somebody can make a call with one gas and then the target gets included in the axis list. It is sort of an attack vector. So I think that the current spec is okay.
Perfect, thank you. Awesome. I think we have alignment on that point in this case. And then the last agenda item for the specs was the JSON RPC endpoints. I think clients are already for DevNet 2 having the JSON RPC endpoints implemented. Is that the case for all clients, or is there a client that won't have the JSON RPC already implemented until next week? Great. Then we have another agenda item by Stefan. Stefan, you wanted to talk a bit about standardized alter traces.
Yeah, I just thought about generally how could we approach kind of in a standardized way testing the performance gains of BALs. And one of the most standard ways to capture these insights is with open telemetry traces. And I think there are two clients that have that implemented, Geth and Reth. But I think Geth is in the process of adding that. I can share the document in the chat. It's a little bit of a long shot, but I wanted to maybe see if we can just use it as a way to brainstorm exactly what kind of metrics block level accesses will add that we want to capture, that we want to follow in a more structured fashion. And would be good that we can get kind of the ball rolling and communicate how best we can extract these metrics. I mean, this document is a suggestion to use open telemetry, but of course, that's not a hard requirement. If other clients might do it differently, but in general, it would be good if we align on exactly when we capture the timings. For example, the prefetching is one of the important elements of the BAL. So how long does it take to prefetch everything? Have you implemented the prefetching the same way as other clients? Does it make sense that we capture it all in a standardized way? And then how well does the parallel execution work? Like how many transactions are running in parallel? That would be really nice to see and to visualize. I would really like to get something like that running for all of the clients in Kurtosis. So yeah, that's why I created the document, and I'm very happy to take any comments or feedback on it.
Awesome, thank you. I see, Joachim, you have your hand up.
Yeah, I know that Stefan, you have already talked to Carlos, but Carlos is also, I'm not sure if this works in parallel, but he has posted this research post about adding some more general metrics, and I think it will be helpful to coordinate this, like maybe getting like these general metrics standardized, and then also on top of that the ball metrics, because then otherwise we will do two things. Well, not in parallel, but yeah, I think you get the point. So the question is, yeah, maybe work together with Carlos on these metrics.
Yeah, for sure. His metrics are a little bit different than mine, because I like built on top of kind of what he was working on and just focused on block level access lists. So his is just generally to identify, I think, execution metrics, but this does not consider vows yet. And that's kind of the spec that I wrote to add on top of that.
Ah, okay.
And
So it's already written on top of this thing. Okay.
Yeah, that's the idea. And in general, it's not just to reiterate, it's not a requirement for DevNet 2, but what I would like to have at some point is to be able to have some visualization of these metrics in Grafana or something like that, to be able to export them. And to have that in Kurtosis would be the first step. That would be very nice.
Awesome, thank you very much. Yeah, please have a look. Let's make sure that we get those metrics implemented such that we can then actually benchmark and test if the optimizations make sense, and especially get some certainty that clients are doing the same and getting the same out of the optimizations. This is great. Thanks a lot, Stefan. Perfect. Anything else on that topic? Otherwise, this would bring me to the last topic, namely, one thing that we should discuss is how we would deal with malicious block level access lists, basically with block level access lists that are wrong. But of course, for such block level access lists, we must make sure that we're able to invalidate the block that contains such a wrong block level access list as early as possible in the process. And let me actually quickly share my screen. Let me actually try to do so. Can you see my screen already?
I see a black screen and a mouse.
Okay,
that's correct.
Interesting, no? Because it already showed me in the preview that it will be a black screen, but let me quickly try something here. Okay, seems like the sharing is not working as expected. Then I will just post, or maybe can someone else share? Jochen, does the sharing work for you? Could you share the screen, theoretically?
I can. Yes, I can.
Okay, could you then open a link for me?
Yes. Let me first share my screen.
Perfect.
This shows the local time.
Right, perfect.
I hope.
It does.
Okay, great. And what should I
And I will now just post the short presentation I have here into the chat so everyone can even follow it live, but you should be able to open it.
Yes, just tell me what to do.
Perfect. Yeah, just click on slideshow for the first slide. Or for the second one already. Okay, so just to quickly introduce you into the topic, we can go one slide back, Jochen, please. Just as a quick intro, so this is how I think of block execution today. So today you don't have a block level access list. So what happens is you first do some I/O in the block, then there might be some execution in the after that there might be again an S load, and you have to go to disk again, and so on. And at the end, right after our virtual execution deadline, there is also the state root calculation. This is basically the last thing we do before we say a block is valid or not. Now going to the next slide, the picture changes a bit with block level access lists. First of all, we can ignore the gas limit here. This is just a random number showing us, okay, we have now scaled from 60 to 30 million. So blocks are actually bigger already. And the best thing we get from block level access lists is that we can now parallelize between batch IO. Then there is still some IO, for example, IO that happens in the very first transactions when the state is not yet cached through the batch IO. You might still need to go to disk. And then there is execution and the state root calculation happening in parallel. And this is essentially a block how it might look with block level access lists. Let's go to the next slide. This summarizes it again. So essentially the state locations in the BAL are very useful for batch IO. Most of the state that we need during execution will already be pre-cached, and the block gas limit can quite significantly be increased. So this is like the happy case. Let's go to the next slide then. So now think of a malicious proposer or a malicious builder. And what this builder does is the following attack scenario. So you would build, so let's start at the very beginning. What do we try to exploit here? So a malicious BAL would exploit the fact that in our block level access list, we don't map state locations, so the reads, how we tend to say, we don't map them to transaction indices. So from the perspective of a single transaction, you cannot really know are the state locations in the BAL correct or not, because they are not mapped to any transaction index. So what a malicious BAL would now do is you would try to declare as many garbage storage slots as possible. So essentially, a malicious proposer could fill the BAL with garbage storage slots. So far, so good. So if you fill it with completely garbage and you fill it full with garbage slots, then this might be quite easy to detect for any client because we can enforce a maximum number of storage slots in the BAL. And this is quite easily derivable from the block gas limit. So we should probably do that anyway. Like have a cap of how many storage slots can there be in the block level access list just by derived from gas limit divided by the cost of accessing a storage slot. But now what we could do is, what I have on this first iteration point here, creating a malicious BAL that doesn't use like naively the full gas limit for the transaction, but the full gas limit minus one max size transaction. So essentially, assuming like 150, 200 million gas, you would use all of it except 16 million, 16.78 million for declaring storage slots in the BAL. So this is like the number of storage slots you would put into the BAL. And then in the same block, the transactions would actually only do heavy computation. So this is like the attack. You would have a BAL with garbage storage slots, many of them, and you would have a block with transactions that do heavy computation. And now the question is, when is the first time that clients could figure out that this block is actually invalid? Right, and this is something we have to think about because, of course, now assuming we parallelize all transactions on a separate core, right? Assuming you have an infinite number of core or you have 8 cores and there are 8 transactions, doesn't matter. From the perspective of each core, you can validate that the state diff is correct, right? You have a definite validation there. But with regards to storage keys, because they are not mapped to transaction indices, you cannot really tell if this malicious BAL that only contains garbage is actually valid or not on each core. So what you would need to do is you would have to actually execute all transactions. And as said, they only do heavy computation. And only after executing all transactions, you would basically be able to sync your cores and compare which storage slots each core saw. And only then you could tell, okay, this BAL must be invalid because the transactions never accessed what is in the block level access list. And in this malicious scenario, what you would get is basically a proposer would sacrifice his block because you would end up with an invalid block, but you would cause the prefetch process to be completely useless, right? The batch IO process would basically fetch completely useless storage keys from the disk and put them into the cache. And at the same time, we would engage in quite expensive computation because we would still execute those transactions. And while executing each transaction in parallel, we would think, okay, those storage slots are not accessed in this transaction, so they must be accessed in another transaction on a different core. And then the question is, okay, how fast can clients fail such a block? Let's go to the next slide. Or even to the next one. Actually, go to the next one. Sorry, go 3 slides back. I thought I had another slide there. 2 slides, sorry. Right, so this is how the malicious block would look like. It would come with a lot of batch IO, and it would still require, actually it would not come with any IO. This is actually wrong. It should only have execution, but there would be a long tail of batch IO for garbage slots and a lot of execution happening. And if we go to the next slide, this would essentially mean that the state locations in the BAL give us nothing anymore, because the worst case having the state locations would be the same as the worst case not having the state locations. And this worst case would be an invalid block. And this would essentially mean we cannot scale as much as we want, which is of course sad. Let's go to the next slide. And there's 3 possible ways forward. So the first one, the simplest one, is we do nothing about this problem. It means we can get quite far, I think, with having like caps on the BAL itself. For example, in the block level access list, we can already tell that if we see a certain number of storage slots, that each storage slot must come at least with 2000 gas, right? Because that's the least you need to access all of those storage slots. And if there is a BAL that already contains too many storage slots for what is realistic within the block size, within the block gas limit, then we can already fail those BALs earlier. And then also a sub point under the do nothing is we can keep track during execution. Let's say you have 4 cores and there are 8 transactions. Then if you keep track during execution of which storage keys have I already accessed and how much gas was already spent, then you can fail the block early on, because you would realize, okay, the transactions I just executed, they didn't touch any of the storage keys. So all the storage keys in the BAL must still be touched, but there's not enough gas available at this point in time. So I can fail the block early on without executing all transactions in that block. So this is one option, and probably the simplest. I'm just not sure if the worst case would actually be the same as the worst case without even having the storage locations at all. The second least complex option would be we remove the state locations. So this is basically something that is anyway to be decided if we keep the state locations in the BAL, and this depends on the benchmarks we get. But one of the benchmarks we should definitely do is test such a malicious block. Essentially having a malicious proposer that submits a malicious block level access list that causes clients to waste a lot of time and then figuring out that the block is invalid very late into the process. And the last option, which would probably be the most elegant solution to this specific problem, would be for all state locations in the BAL that are currently, of course, not mapped to any transaction index, we actually map them to the transaction index when they are first accessed within the block. This would mean we don't have any duplication, because if a storage slot is kind of like changed, it would still not appear twice as a read again. So this would not change compared to today. But what would change is that each account would come with a first access index, and each storage read would come with a first access index. And I already did some experiments, and it looks like with today's gas limit, this would increase the average BAL size by approximately 4%. So we are only talking about a 1 to 3 byte number here. So it's quite insignificant from a size perspective, but of course add some logic again to it. Also, it touches the worst case ball size, which would increase from 0.2 megabyte to 0.97 megabyte. This is like negligible. We can totally ignore that because as long as the worst case ball size still stays below the call data block, and we are still like half a megabyte smaller than the call data block, I think we are fine because we're not creating like a new DOS vector. Then the next point, it allows clients to prefetch storage slots in the correct order, which might be quite nice because today with the storage keys or with the state locations not being ordered, there is another worst case scenario where the keys you need first are actually the lexicographically last in the ball. So you would read them last while you need them earlier in the block. So this would be prevented. And one nice thing is that we would still not have any duplication of addresses and storage keys. So the ball would basically, from a size perspective, it would stay quite compact. But yeah, it would change something, and suddenly we're not talking about removing the state locations anymore, but actually adding indices to it. So yeah, this is of course a lot that I presented right now. I guess we won't find an answer about this today, but I'm curious if clients have already thought about this, like especially how do we want to invalidate a block as early on in the process without risking that we do a lot of batch IO and we also do a lot of execution and then only figure out that the block is invalid very late into the process. And yeah, getting nothing out of the batch IO. Yeah, any thoughts on this? Yeah, Jochen, go ahead.
Yeah, like maybe one comment which I just realized, because now we are talking about like we have to realize the current way where we invalidate invalid blocks. That means that we have to first sequentially execute the entire block, and then well the simplest example on how to construct like an invalid block is to just construct a valid block, but just change the state root at the end. So you would only realize at the end that the state root is incorrect. And what we are talking about here is like we already have the parallel execution. So if we would compare this worst case or like this situation to the current situation where we don't have the block access lists, then it likely still is like a very big improvement. I just wanted to raise that point for the perspective of this. But yeah.
Yeah, this is very true. So it's not like setting us back that far, but it's more like comparing the block level access list with state locations with the block level access list without state locations. This malicious block would essentially get us into the same spot. Or yeah, basically the same spot where we waste almost all of the batch IO and still have to do like full execution. And of course, we can put numbers to it, right? Let's say we have 3 seconds for execution and we can support the gas limit of 500 million. I don't know, doesn't matter that much. But if we kind of scale the gas limit to a point where leveraging the worst case batch IO and leveraging the worst case execution would exactly get us to that boundary, right? Then suddenly we find out that there is a worst case block where you get nothing from batch IO. So this would definitely mean we have to sacrifice some scaling there, which would of course be bad because at this point we should then decide for removing the state locations from the BAL directly without doing nothing. Yeah, Jared, go ahead.
Yeah, so I guess I'm not quite understanding how adding first access to the BAL prevents the case where we have to execute the entire set of transactions, because with parallel execution, there's not really any guarantee about what order transactions will be executed in. So to validate this first access, we still have to I mean, because at any given point, if we access a storage slot, it might not be the first access of that slot in the block, and so we still need to execute the entire set of transactions to validate the first access. And once we, I mean, if we have to execute the entire